Okay, so here we're going to look at this question. Calculate the total resistance in the figure below. Calculate the total resistance in the figure below. So we have this diagram, this figure. So we have this figure, which is composed of many resistors, right? And we are asked to calculate the total resistance in this figure. So the first thing that you want to do when looking at this diagram, when looking at this figure, is to resolve the resistance here, right? I have 3 ohms here, I have 5 ohms here, and I have 5 ohms here. They are connected in parallel. What that means is that they are connected to a common terminal, right? So I will have to resolve this parallel connection first. So for parallel connection, for parallel connection, I have that 1 all over ROT, which is my total resistance, is equal to 1 all over 3, which is this resistance here, plus 1 over 5, plus 1 all over 5, which is this resistance here. So what I'm doing here is that I'm trying to resolve this parallel connection so that it will be in series with this, right? So this will be 1 all over ROT, which is the total resistance, is equal to. The next thing I will do is to look for the LCM of 3, 5, and 5, right? So let's look for the LCM of 3, 5, and what? And 5. So what can go? 3 can go. 3 divided by 3 will give me 1. 5 divided by 3 cannot, so I will drop that. 5 divided by 3 cannot, so I will also drop that, right? What can go again? 5 can go. This will be 1. 5 divided by 5 is 1. 5 divided by 5 is 1. So the LCM of 3, 5, and 5 is, so the LCM is equal to 3 times 5, which is equal to 15, right? So I'll come here, write my 15 here as the denominator. So 15 divided by 3 will give me 5. 5 times 1 is 5. So that will be 5 plus 15 divided by 3. 15 divided by 5 is 3 times 1 is 3. So that will be plus 3 plus 15 divided by 5 is what? Is 3 times 1 is still 3. So that will be 1 all over ROT, which is the total resistance, is equal to 5 plus 3 plus 3 will give me 5 plus 3 is 8. 8 plus 3 will give me 11. So that will be 11 over 15. So the next thing I would want to do here is to cross multiply, right? So that will give me 11 times ROT will give me 11 ROT, is equal to 1 times 15 will give me what? 15, right? So what I will do is to divide both sides of the equation by the coefficient of ROT, which is 11. So my ROT, which is the total resistance, will be equal to 15 divided by 11, and that will be equal to, so 15 divided by 11, that is equal to 1.36, which is approximately 1.4. So this is approximately 1.4 ohms, right? So these are answer for this parallel connection. So what I now have in essence, I now have a resistor that looks like this. I have a connection that now looks like this. This is 4 ohms, which is this 4 ohms that is here. And then I have 2 ohms here, and then I have 1 ohm here, and then I have resolved this into a single what? I've resolved these 3 resistance into a single resistance, right? And what I got is what? what I got is 1.4 ohm. So 1.4 ohms, right? So this is what I now have in essence, right? So the next thing I would want to do is to resolve these 2 ohm and 1 ohm so that it will be in series with this. So it's to resolve this parallel connection. I've already resolved this and I got 1.4 ohm. So the next thing is to resolve this parallel connection so that it will be in series with the rest, right? So for the next parallel connection, for parallel connection, for parallel connection, right? I have my total resistance, which is 1 all over RT, is equal to 1 all over 2, which is this 2, plus 1 all over 1, which is what? This 1, right? So that would be 1 all over RT is equal to the LCM of 2 and 1 is what? Is 2. So I'll put down the 2 there. 2 divided by 2 is 1. 1 times 1 is 1. Plus 2 divided by 1 is 2 times 1 is 2, right? So that will be 1 all over RT is equal to 1 plus 2 will give me 3 over what? Over 2. So the next thing I want to do is to cross multiply, right? So RT times 3 will give me 3 RT is equal to 1 times 2 is 2. So my RT will be equal to 2 divided by what? By 3. So RT, which is the total resistance, now will be equal to 2 divided by 3. So 2 divided by 3, that is equal to 0.67, right? So that will be 0.67, 0.67, right? Ohms. So what do I have in essence? What do I have in essence? I have a resistor that now looks, I have a connection that now looks like this. So let me put a line here to share this, right? So I now have a resistor that looks like this, a connection that looks like this. This is 4 ohms, which is this 4 ohms. I have resolved this 2 and 1 ohm into a single resistance since they are in parallel connection, right? And what I got is what? 0.67 ohms. So I have 0.67 ohms. Then another connection, which is 1.4 ohm, right? 1.4 ohms. So I have resolved everything to be in series with one another. So first of all, I resolved these 3 ohm, 5 ohm, and 5 ohm, which are in parallel connection, into a single resistance, and I got 1.4 ohm. Then I resolved these 2 ohm and 1 ohm, which is what I did here, into a single resistance, and I got 0.67 ohm. So they are now in series with this 4 ohm. So therefore, for the series connection, for series connection, total resistance, which is RT, will be equal to 4 ohms plus 0.67 plus 1.4, right? So if I add that, 4 plus 0.67 plus 1.4, that will be equal to 6.07, right? So my total resistance RT will be equal to what? 6.07 ohms. So this is the final answer to this question.